All right, guys, right triangle trig. There's a couple things I'm going to bring to your attention. I'm going to talk about a bunch, okay? Your test for this is on Thursday, 4-1, 4-2, 4-3. You will be allowed the use of a calculator on your test, but you have to make sure that you're paying attention to the directions. Some questions are going to say, round your answer to the nearest whatever. That means decimals are okay. Some are going to say you have to have an exact answer only. Exact. When I say exact means no decimals. Meaning, if you end up with something like the square root of 2, does the square root of 2 simplify pretty? When you hit square root of 2 in your calculator, you get a gross decimal, so you would leave your answer as the square root of 2. It's important that you rationalize. Some of you on your quiz, you left answers like this, 2 over square root of 2. I took points off for that, guys. You had to rationalize. Some of you left your answer like this. Didn't simplify. Little things like that you guys have to do, you have to pay attention to. All right? So, today we're talking about right triangle trig. That means your angle in the corner of your triangle is a 90-degree angle. You guys have all heard about SOHCAHTOA, right? SOHCAHTOA. Probably since middle school. With right triangle trig, that is the mnemonic device to remember what to put over what ratio goes over what. In 4.2, I gave you an angle on the unit circle, and I said, here, find all 6 trig functions, sine, cosine, tangent, and their reciprocals. We're going to do the same thing here, but now we're using a right triangle. We're not using our unit circle or anything. We're using a right triangle. So let's understand the workings of a right triangle. If you guys have seen this a million times, you're like, I already know this. Okay, great. All right, you're going to be given an angle written as theta. This is what we call, this is our reference. Okay? It's important to know or to put theta in the correct place. If you guys draw your own triangle, I'll show you what I mean by that in a second. But when you have your theta, the side across from theta is your opposite. The side next to theta is your adjacent. Right? If theta was up here, then those two things would switch, right? It's very important that you have the reference there. What does not change is the hypotenuse. Your hypotenuse is always the longest side across from the right angle. All right, when I say the mnemonic device SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA is opposite. Tangent is opposite over adjacent. All right, everybody remember that? Okay. All right, scooting, keep scooting. All right, when we talk about our reciprocal functions, all right, think about this. If I have sine is opposite over hypotenuse. So what is my cosecant? Hypotenuse over opposite. You literally just flip them. So if cosine is adjacent over hypotenuse, what is our secant? Hypotenuse over adjacent. Great, God bless you. And if tangent is opposite over adjacent, then my cotangent is adjacent over opposite. Now, we are talking right now only about angles that are between 0 and 90 degrees. That means you're in the first quadrant. God bless you. What do you know about the x and y values in the first quadrant? They're always going to be positive. So right now, for what we're talking about today, everything's positive. All your trig functions are going to be positive. When we go to 4.4, we're going to talk about things in all 4 of the quadrants. So that'll change your signs, but we'll talk about that later. All right, anybody have any questions? We're good? Okay. So here's what I just talked about. Here's your reciprocal, here's your functions and their reciprocals. Opposite is abbreviated OPP. Adjacent, ADJ, it's next to theta, opposite is across from, and then hypotenuse, HYP. It's the length of the longest side across from the right angle. All right, so think about this. If I have a right triangle, is there a theorem I know that if I'm missing one of the sides, I can figure out what the missing piece is? Yes, sir? Pythagorean theorem. Good. A squared plus B squared equals C squared. We're going to use that a lot, guys. What are A and B? What part of the triangle are they? The legs, right? They're the horizontal and the vertical. The x and the y, right? This would be our x value. This would be our y, meaning left, right, up, and down. And then your hypotenuse is always c. Always. Everybody with me? I know we always remember the Pythagorean. All right, so let's go over this very quickly. This is how I suggest that you work on these problems, just so we don't make any silly mistakes. Okay, tonight's web assign is 100% mechanical stuff. I took off any word problems. We're going to work on those the next 2 days. But it's just practicing this stuff. It's due tomorrow morning. If you are given a picture, you should highlight, you should figure out where theta is in the triangle. Then, in reference to theta, you can figure out what the sides are. What is 4? 4 is your opposite side. What is 3? Your adjacent. So what is this one? The hypotenuse. But they didn't give me the measurement. Can I figure it out? Yes. If I use a squared plus b squared equals c squared. What am I looking for in this triangle? A, B, or C? I'm looking for C. I'm looking for the longest side. So I'm just going to say 3 squared plus 4 squared equals c squared. Exact answers only. Look, do you see how it says exact value? So if this doesn't turn out nice and pretty, you leave a radical in your answer. Now, would it matter if I put 4 squared plus 3 squared? No, same thing, right? Just make sure your legs are on one side of the equal sign. So 3 squared is 9 plus 4 squared is 16 equals c squared. Agreed? What's 9 and 16? So 25 equals c squared. So what is c? C is 5. Now, c is actually plus minus 5, right? Because you actually put the square root on. But why wouldn't I use the negative? Can't have a negative length, right? We don't deal in negative lengths. So here's my suggestion, just to keep yourself straight. There's a lot going on this page, right? If you're going to find all 6 trig functions, this is what I would do. I would say, okay, I have to find all 6 trig functions. Let me just write down, what was the value of my opposite side? It was 4. What was my adjacent? 3. And then what did I find the hypotenuse to be? 5. I don't have to look at my triangle anymore. I don't have to go, okay, wait, which one was the opposite? Which one was the adjacent? Once you figure out what the 3 sides are, I would write down the numbers next to their side abbreviation, and then you don't have to look at the triangle anymore. Because sometimes, guys, when we're trying to go through things quickly, we take a look at this, and then we look back at our paper, and we just, you make a little mistake. There is a huge difference if you switch where the 3 and the 4 go. 60% of your trig functions will be wrong. So we're going to go through this one fairly quickly because this is a very straightforward problem. Sine, remember, is opposite over hypotenuse. So it's what over what?
4 over 5.
4 over 5. Good. So go to the right. My cosecant is going to be hypotenuse over opposite. So it's what? 5 over 4. All right. Cosine is adjacent over hypotenuse. So it's 3 over 5. Then my secant is going to be hypotenuse over adjacent. So it's 5 over 3. You just flip it. My tangent is opposite over adjacent, so it's 4 over 3. Good. And then my cotangent is adjacent over opposite, so it's 3 over 4. Simple enough? Now, is every problem I give you going to just be those nice, pretty whole numbers? And you're like, oh my God, thank you. No, but it's the same concept, right? Same concept. Look at the next problem. I'm going to do one of these. Which one do you want me to do? 1 or 2? Let's do 2. All right. Generally, I will give you a triangle, and I'll give you 2 of the sides. You have to find the third one. For the sake of time, we didn't do that on this one. Actually, let's change this for a second. Change this to 11 and this to 10. Why did I do that? Why did I change those two? The hypotenuse has to be the longest side. So change that. But what the important thing here, guys, is if there's a missing side, whether it's a leg or the hypotenuse, use the Pythagorean theorem to find it. Now, this is what I'm talking about, how you can simplify your process here. If you are given a triangle, there's a picture, identify where theta is. And then figure out the sides in reference to theta. What do you know 11 is? 11 is your hypotenuse. What is 10? The opposite side. And then what is the square root of 5? Adjacent. All right, if some of you are sitting here going, how is she getting that? And you don't want to ask right now, that's okay. See me after class, come see me after school, send me an email. We can go over that. It's no big deal. But instead of trying to do all your trig functions now from this picture, I think it's easy to just simplify and say, okay, what is my opposite side? 10. What is my adjacent side? Square root of 5. What is my hypotenuse? 11. Now, this is all you have to look at.
Would we have to rationalize the denominators?
Yes. Yep. We're going to have to rationalize the denominators. But once you kind of figure out what your three sides are, it's just easier to just have a little list rather than looking back at that triangle, looking at your arrows and stuff like that. So remind yourself again, sine is opposite over hypotenuse. What is my opposite side? What's opposite? 10 over what? 11. Are we good? Okay. Cosine, adjacent over hypotenuse. What's the adjacent? Square root of 5 over 11. We good? Okay, cool. Tangent is opposite over adjacent. What's the opposite side? 10 over the adjacent is the square root of 5. Are we good? No. What's the problem? You can rationalize. You have to. So multiply top and bottom by the square root of 5. So I get 10 root 5 over 5. Are we good? No. What do I have to do? I have to simplify. 5 goes into 5 once. 5 goes into 10 twice. So I have 2 square root of 5. Always, always, always simplify. We want to leave exact answers. We don't plug that in our calculator and get some crazy decimal. Exact answers only. So now we're going to go through and do our reciprocals. What is the reciprocal of cosecant? Okay, but what is the trig function that's reciprocal? Sine. Remind yourself of that. Some of you guys got that confused. If sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So it's what over what? 11 over 10? Okay, so what's the reciprocal of secant? Cosine, right? So cosine is adjacent over hypotenuse, so I need hypotenuse over adjacent. What's the hypotenuse? 11 over the square root of 5. Uh-oh. What do I do? Rationalize. Multiply top and bottom by root 5. Good. So I have 11 square root of 5 over 5. Can I simplify anything? No. Is that the greatest number in the world? No, but that's okay. And now we have cotangent. What's the reciprocal of cotangent is tangent, right? So instead of opposite over adjacent, it's adjacent over opposite. So what over what? Square root of 5 over 10. Can I simplify anything? No. Guys, the square root of 5 is not the whole number 5. You can't simplify the square root of 5 over 10. It just stays just like that. Any questions? All right, so that was the example given. If you are given a picture, there's going to be times when you aren't given a picture. You can always draw one, but you don't have to. Some of you like to visualize things, and that's great. But let's talk about this for a second. They told me that the cosine of theta is 5 over 8. That's telling me a lot of information. What is that telling me?
That the adjacent is 5.
Perfect. Because cosine is adjacent over hypotenuse, isn't it? So they told me that my adjacent side is 5 and that my hypotenuse is 8. Do you guys see that? So if I know that my adjacent side is 5 and my hypotenuse is 8, can I figure out the opposite side? How? The Pythagorean theorem. All right, so think about this. A squared plus B squared equals C squared. What do I know? I know one of the legs, so I know that this could be here. And I know what else? The hypotenuse. I know the C. You guys have to put everything in the right spot. And once you do, this is easy. All right, so I have a squared plus 25 equals 64, right? Now what? Subtract 25. Okay, so what is 64 minus 25? 39. All right. And then I take the square root. So I have a equals the square root of 39. Does that simplify it all? No. It happens to be a gross number. Who cares? Here are the three things that I need to find all my 6 trig functions. If you wanted to draw a picture, go for it. Just make sure wherever you put theta that you have the root 39 is opposite and your 5 is next to, adjacent to. But if you were now going to find all of the trig functions, okay, great. So sine of theta is opposite over hypotenuse. So what is my opposite? Square root of 39 over my hypotenuse is 8. Do I need to do anything with that? No. So let's do the reciprocal of sine. Reciprocal of sine is cosecant. That's going to be hypotenuse over opposite. Well, if I flip that, guys, I get 8 over the square root of 39, right? Are we good there? No. I have to rationalize. So I have 8 root 39 over 39. Can I simplify it all? Yes or no? No. So just leave it. That's fine. So let's move along to cosine. Cosine. Wait a second. Didn't they already give me the cosine? Wasn't that given? Yes. Yeah, what's cosine? 5 over 8. So then I know that my secant is what? 8 over 5. Perfect. What's the next group we're going to do? Tangent and cotangent. So tangent of theta is opposite over adjacent. What's the opposite side? Square root of 39 over the adjacent is? So square root 39 over 5. So my cotangent is adjacent over opposite, so it's 5 over root 39. Can we leave that? No. I need to rationalize. So I have 5 root 39 over 39. Can I do anything with that? No. So there's our 6 trig functions. So just because they don't give you a picture, no big deal. You guys know what all of the trig ratios are. Opposite over adjacent. Hypotenuse over opposite, something like that. So you guys can figure out, given the information, all of the sides, then the trig functions. So if you come over here to number 4, 7. 7 over 1. Very good. Any whole number is over 1. So now think of what cotangent gives you. Cotangent is what over what? Adjacent over the opposite. So you already have 2 things. I always write opposite first. I don't know why. I just do. So opposite is 1. Adjacent is 7. What am I looking for? My hypotenuse. Do I know a theorem that I've given 2 sides of a triangle that's a right triangle, I can find the third side? What is it? Pythagorean. A squared plus b squared equals c squared. In this case, guys, what are the 2 things I know? I know the opposite and the adjacent, so I'm trying to find the what? So 1 squared plus 7 squared equals c squared. What is 1 squared? 1 plus 49. So 50 equals c squared. Take the square root, and I get c equals the square root of 50. Is that simplified? Is the square root of 50 simplified? No. Is the square root of 50 a perfect square? No. But can I break it down? Yes. This is the same as 25 times 2, right? So c is 5 root 2. That is your exact answer. You guys need to do that. So 5 square root of 2. Now that I have my information, I can find all 6 trig functions very easily. Everybody with me? Okay, so let's do the sine. Sine of theta is opposite over hypotenuse. What is my opposite side? 1 over the hypotenuse is 5 square root of 2. All right, that's a problem. Now, when you rationalize, guys, you do not have to rationalize by the entire denominator. You can rationalize by just the root. If you do the whole thing, that's fine. You just have to simplify more later. But if I rationalize by the square root of 2, all right, everybody stay with me here. 1 times root 2 is the square root of 2. In the denominator, I have 5 times the square root of 4, right? Because the square root of 2 times the square root of 2 is the square root of 4. Agreed? What is the square root of 4? And what is 5 times 2? So this is really the square root of 2 over 10. You don't have to do this math. Like, you don't have to show me. I wanted to explain it. Can I simplify the square root of 2 over 10? No. That's it. The square root of 2 is 1.17 something. 10 does not, nothing goes into that. It's the square root of 2 divided by 10. That's it. So now if we're going to find the reciprocal, what's the reciprocal of sine? Cosecant. Whoops. Cosecant. So it's hypotenuse over opposite. So it's 5 root 2 over 1. Do you have to put the 1? No. But that's it. Good job. So now let's find the cosine. Well, cosine of theta is adjacent over hypotenuse. What's the adjacent side? 7 over your hypotenuse is 5 root 2. Again, square root of 2. Cannot leave that in your denominator. So I have rationalized by root 2. So I have 7 square root of 2 over what? 10. Perfect. Can you simplify it all? Nope. So we're just going to stay just like that. So what is the reciprocal, guys, of cosine? Secant theta is going to be hypotenuse over adjacent. Well, my hypotenuse is 5 root 2. And my adjacent is what? 7. Can't do anything there. And then I already have my tangent and cotangent, don't I? Since they gave me cotangent of theta is 7. So what's my tangent? 1 over 7. Good. Flip it. So do you have to have the picture of the triangle? No. I can give you one trig function. And by giving you one trig function, I'm giving you 2 sides of the triangle. You just figure out the third one. We good? You guys okay? All right. There's a couple questions on your web assign tonight that has to do with this slide. So just make sure you refer to it tonight. Do you guys remember your 30, 60, 90, and 45, 45, 90 triangles? Remember in geometry, you were supposed to memorize that pattern? Some of us didn't. And then again in Algebra 2, we were supposed to memorize that pattern, and some of us didn't. Okay. We're going to go over this a little more. This is a 45, 45, 90. What do you know about both of the legs? They're the same. The pattern is 1, 1, and this is square root of 2. If you have a 30, 60, 90, everybody remember the pattern? 1, 2, square root of 3. We're going to go over that because there's going to be questions on your test that's going to give you values and it's going to say, give me the exact answer. That means you have to have radicals. You have to know the pattern. We'll go over those a little more tomorrow, Wednesday. You guys have a calculator in your hand. I understand that. So if you hit sine 30, it would tell you 0.5, 1/2. These are the trig ratios at the 30, 60, 90, and 45, 45, 90. It's your sine, cosine, and tangent at those exact things. If you guys are looking at a unit circle, what would your sine value be? What part of the ordered pair? Your sine is the y. Your cosine is the x. And then your tangent is y over x. So that in a calculator, that's how you would get that. Take the ordered pair at sine. The y value is 1/2, that sort of thing. It all goes together. All right, now we're going to talk about some word problem stuff. Now, the word problems, guys, okay, we're going to practice this a bunch. I have 2 problems I'm going to go over with you right now. But we're going to practice this a whole bunch, I promise. But it's really, really important that you guys understand what the question is asking. Because everybody in here can solve a right triangle. It's the matter of setting up your right triangle. That is the that is the application portion that you're going to be tested on. You cannot come up to me and be like, are they looking for the hypotenuse here? That is what the question is going to be asking you. So we need to understand a lot of vocabulary in order to do this. Now, we're talking, about right triangle trig, right? So every time you have a word problem, you should draw a picture. What kind of a picture should you draw? A right triangle. I always draw my right triangles like this. I don't know why. If you want to draw it like this, up here, backwards, I say it's backwards, that's just me. You're more than welcome to. But you're going to be given problems in a variety of manners. And sometimes they're going to tell you the angle of elevation. And sometimes they're going to tell you the angle of depression. What does the word elevation mean? Up, looking up. What does depression mean? Down, okay? So we're going to talk over here about angle of elevation. All right, when they tell you the angle of elevation, it represents the angle that is formed with the horizontal. What part of my triangle is the horizontal? The left to right or the up and down? The left to right. Your angle of elevation is always going to be formed with the ground. It's going to be somebody is looking up at the top of a building. Somebody's looking up at the top of a tree, something like that. But when they give you the angle of elevation, it's always formed at the horizontal, at the bottom of your triangle. I always draw my triangle this way, so it's always the bottom right. Angle of depression, and we'll talk more about this tomorrow, they're also giving you the angle of elevation. Just depends upon how you want to look at it. When they tell you the angle of depression, and you look at this picture that they gave you, this right here is the angle of depression. So there's two ways you can figure this out. If you're going to solve this right triangle, you don't need the angle of depression out here. You need this piece in here. So how would you solve for that part of your angle? 90 minus the angle of depression. Good. Because you want the inside here of this triangle. Now, sometimes that can be confusing, and you guys are like, wait, I just don't understand that. So there's another way you can look at this. And again, we're going to talk more about this tomorrow. But if we go back to geometry, which some of us absolutely love, so that's great. Do you guys agree that that's a parallel line? And down here I have another, these two are parallel. They're horizontal lines that are parallel. What do you know about this angle here and this angle here? They're the same. If they give you the angle of depression from the top of a triangle, that is the same as the angle of elevation from the bottom. So there's two ways you can look at it. And again, we'll go over this again tomorrow. But you can either say, okay, the angle of depression, to find that top angle that's formed, you could say 90 minus. Or if you want to always use angle of elevation, whatever the depression is from the top, you put the angle of elevation, that same number in the bottom corner. That makes sense? All right, let's go through some things. Again, we're going to talk more about this tomorrow, but I'll do some questions here. There's going to be a lot of vocabulary, and I don't mean math vocabulary, but we're going to label this triangle. I'm going to call this my Y and this my X. Why am I using those two letters? What does X represent on our coordinate plane? Left and right, right? The horizontal. What does Y represent? Up and down. So they're going to give you angle of elevation, angle of depression, whatever. And they're going to say, how far is the distance from the base of the tree to where the surveyor is standing? What are they talking about when they say how far away from? The X value, the Y value, the hypotenuse. If I want to know how far away something is from the base of a tree, from the base of whatever, tell me. The X. This is usually distance away. All right, I'm just giving you guys some things to kind of think about. If I want to know how tall something is, the height of, what letter am I looking for? The Y. Okay, this is usually tall, height, something like that. What about the hypotenuse? What are some things that could be, think about a word problem, like that would be asking for the slanted part of the triangle? How about a ladder leaning against a building? A ladder leaning against a house. Leaning against. What about a ramp? A skateboard ramp, right? What would a ramp be? What part of the triangle? The hypotenuse, the ramp. All right, another one that they use a lot. And again, we're going to go over these tomorrow. We're going to draw pictures, all that stuff. But think about a kite. How many of you have actually ever flown a kite? Or attempted to, okay? When you're at the beach, it's really windy, and you stand there with your kite. Do you stand there like this with the string, and it just goes straight above your head? No, the kite is usually like this, right? It's at an angle, and it's flying out this way. So they'll talk about the length of the string of a kite. What part of the triangle are they talking about if they say, how long is the length of the string of the kite? This would be the hypotenuse, like a kite kind of problem, something like that. I'm just trying to give you guys some scenarios that it will clue you into what they're looking for. Because you already know this is a right triangle problem. You guys already know the trig functions, SOHCAHTOA, and the reciprocals. So it's important to understand the vocabulary behind these word problems. All right, we're going to do 2 of them today. And then tomorrow and into Wednesday, all we're doing is just working on word problems. Working on setting them up. You guys can all solve once we get it set up. It's the setup part that's the hardest part. So I'm going to reiterate this to you a million times. Some of us are better artists than others. That's fine. But if you have a word problem, you should draw a picture. So the first thing I'm going to say is, oh, I'm talking about right triangle trigonometry, so I'm going to draw a right triangle. I always draw my right triangles in that direction. If you are more apt to draw it the other way, fine. It doesn't matter. I just always do the same thing. But I always have a picture in my mind. It says a surveyor, just read the question. A surveyor standing 50 feet from the base of a large tree. All right, if you have a picture, picture your tree. Is your tree laying on the ground? No, it's just standing up it's a large tree. It's standing up like this. All right, I'm going to wow you with my artistic ability. Get ready. So the surveyor is standing 50 feet from the base of the tree. Is the surveyor in the tree at the top? No, where is this person standing? At the bottom, over here, right? It says 50 feet from the base of the tree. What value did they just give me by telling me that? The x. 50 is down here. The x value. When I say x, guys, it's the horizontal, the left to right. It says the surveyor measures the angle of elevation to the top of the tree. Are they telling me this up here? Or are they telling me this down here? Down. Angle of elevation is formed from the horizontal, from the ground in this case. So they're telling me that this angle is 71.5 degrees. How tall is the tree? What are they looking for? The height, the opposite. They're looking for the height. How tall is the tree? You can use whatever letter you want. If they said, how long would a ladder need to be to reach the top of the tree? What would it be looking for? The hypotenuse. All right, so you have to pay attention to what the question is asking. Now, from the information they gave you, we haven't solved anything. I want to know how tall that tree is. This is my theta. This is the angle that they gave me. What is y and what is 50? Y is my opposite and 50 is my what? Adjacent, okay? So now I have to think, all right, I know a trig function that uses opposite and adjacent. What is it? What is it? Tangent. So I'm just going to set up my problem. Tangent of theta, okay, they told me theta is 71.5 equals opposite over adjacent. Do you guys have a problem right here that says a fraction equal to a fraction? Yes? How do we solve this? Okay, can I just cross multiply? What's y times 1? Y. And then I have the tangent of 71.5 times what? Times 50. Is y all by itself? Yeah. So in your calculators right now, guys, hit tangent 71.5 times 50. Or 50 times tangent 71.5. What do you get? 149. What is it? 4 point, okay, 4 something. Now, last period we did this and somebody was like, I got a negative. Anybody get a negative? Okay. Now, that's a good thing right now as we're starting this, that we get a negative. First of all, we're talking about the height of a tree, yeah? Can the height of a tree be negative? So you should be like, oh, wait a second, something's wrong. Make sure your calculator is in degree mode. Go to mode and make sure it's in degrees. But the beauty of these word problems, guys, is your answer should make sense. If you do this problem and you get a negative number, you should think, wait, I keyed something in wrong. Maybe my calculator's in the wrong mode, something like that. If you're figuring out the height of the tree and you get 2.7 times 10 to the 29th power, does that make sense that your tree is so tall you have to use scientific notation? No. So just little things like that, pay attention to. Now, on a question like this, it'll say round to the nearest. So say I said round to the nearest foot. What would your answer be? 149 feet tall, all right? Your tree is about 149 feet tall. Does that make sense? Yeah. It's a big tree. That's okay. You're in a forest, something like that. All right, this next problem I want to do in 2 different ways. We're gonna answer 2 different questions. So I'm going to call this first one, I'm going to call this A, and then I'm going to change the wording just a little bit so you guys can see the difference between, I can do the exact same problem and change like 2 words, and it's a totally different problem for somebody else. So I know I'm doing right triangle trig, so I'm going to draw a right triangle. Again, draw your triangle however you want. But it says a large apartment building in New York City stands 135 feet tall. What are they telling me? What are they telling me? The height, right? Here's my New York City building. How tall is this building? It's 135 feet tall. The angle of elevation measured from the base of a fire hydrant on the sidewalk is 37 degrees. Okay, they told me a lot of information there. They told me that there is a fire hydrant right here. How far is that fire hydrant from the base of the building is what the question is. But what is the angle that is formed from the base of the fire hydrant to the top of the building? 37. So my 37 goes right here, correct? The question asks, how far is the hydrant from the base of the building? What am I looking for? I'm looking for the X value. I'm looking for this. You guys agree? Everybody with me? All right, so now let's change this to problem B, and then we'll work them both out, and then we're done. All right, I have my same problem. My same New York City building is here. It's still 135 feet tall. Great. I still have my same fire hydrant here. And it's still an elevation angle of 37 degrees. But now, guys, I want to know how long the ladder needs to be to reach the top of the building. What am I looking for in that case? I'm looking for which part? The hypotenuse, right? So if I just change the wording, because someone asked me last year every time I do, is it always tangent? No, it just depends on what they're looking for. The original problem said, how far is the hydrant from the base of the building? Okay, great. I changed I changed one sentence. I said, how long does the ladder need to be that reaches the top? Totally changes your problem. So if we look at A, here is my theta. Right? Everybody agrees that that's my angle of reference that I'm looking at. What is 135? The opposite, good. And what is X? My adjacent. So what trig function would I use to solve this problem? Tangent. I'm going to say tangent of 37 equals the opposite, which is 135. Over the adjacent, which, I don't know, is X. Remember, this is over 1. I have a fraction equals to a fraction. How do we solve that? We cross multiply. So 135 times 1 is 135 equals X times the tangent of 37. Guys, the tangent of 37 is just a weird decimal. All right, you're solving an equation. You want to get X what? By itself, so you're going to divide both sides by what? The tangent of 37, good. So tangent 37. So X equals What's 135 divided by tangent 37? 179.2. So if I said round to the nearest foot, you would tell me that the fire hydrant is about 179 feet from the base of the building, right? From the base of the building. You guys understand that? Where we got that from? All right, so now let's do the second problem that I changed to. I changed it and I said, well, how long would the ladder have to be? Well, in this case, I don't care how far the fire hydrant is from the base of the building. I don't know how long that ladder would have to be. So in that case, this is still my theta. But what is 135 and what is y? 135 is my opposite. And what is y? Your hypotenuse. So guys, this trig function is different. In reference to 37, what trig function would I use? I would use sine. I would say sine of 37 equals my opposite, which is 135, over my hypotenuse. Am I going to get the exact same answer? No. Different trig functions give you different answers. We solve it the same way. 135 times 1 is 135. Then I have y times the sine of 37. I want to get y by itself, so I divide both sides by sine 37, right? And what do I get? How much? It's 224.3. So in this case, guys, when I answer the question, the second question I asked is, how long does the ladder have to be? The ladder would have to be about 224 feet long. This is our ladder if it was, you know, helping somebody at the top of the building. So do you guys see how we had the exact same question? Same height of the building, same angle of elevation, but when I changed the wording and I just look for a different side, it totally changes the trig function that you're using, therefore your answer. Does that make sense? So tomorrow we're going to spend the whole class period. I already put it in modules if you guys want to start looking at it. It's word problem application or whatever, but we're just going to be working on word problems. Figuring out what side is given, what we're looking for, and which trig function to use to set it up. Sound good? Okay, so tonight